Guys, today we're going to look at ohmic and non-ohmic conductors. So let's start off with the idea of an ohmic conductor. So an example of an ohmic conductor is something like a wire. But what is an ohmic conductor? It's something that follows Ohm's law, the relationship between voltage, current and resistance. And it's usually noted by this graph of current against voltage, and the straight line will represent 1 over the resistance. Okay, so what's important about an ohmic conductor is the fact that resistance stays constant, and the fact that in a lot of devices that we actually use, this is not the case. So for example, we'd have a diode. A diode, you can see here that a graph of current against voltage, you can only really see something at 0.6, because beyond this point, below this point, sorry, you have a very high resistance, and this very high resistance means that the current is so low. So for a diode, the current only flows in like one direction, and that's forwards. Now remember the symbol for a diode. It is a start-stop sign with a circle around it and then a line through it. So remember, that is important to note here. And again, that the fact that resistance is not constant. Now we're going to look at a filament lamp. Now a filament lamp sort of follows Ohm's law from this point to this point, but then it kind of tails off. And the reason for this tailing off is because as the resistance increases, the temperature does too. So actually, let's reverse that around. As the temperature increases, the resistance increases too. So to have a summary of what's going on here, you're going to get an increase in heat because of more vibrations. The more vibrations over here cause it more difficult for the electrons to move as we increase the current. So at this increased current level, you're going to have a lot of vibrations, a lot of electrons moving around, and a high temperature. So this increase in current and temperature is going to increase the resistance a lot because of the vibrations, which then in turn actually decreases the current, and that's why you have a saturation off here, because that's the decrease in current generated by the increase in temperature from the collisions colliding together. So hopefully that makes sense. You'll get this sheet if you want to play with it or do whatever you want with it. So yeah, hope that helped. Thanks for watching the video. Bye guys.